Hello everyone, welcome to ICAR Agri Edit, ICAR JRF Physical Sciences classes. I am Nymisha, your mentor for Physical Sciences, and I am currently pursuing my Masters in Soil Science and Agriculture Chemistry from ICAR IRA, New Delhi. And today we are going to see a very important and also an understandable topic, that is soil temperature. We all know what is temperature, like we see from our childhood. The difference between temperature and heat, it's all routine, right? Temperature is nothing but degree of hotness or coldness of an object. That means by seeing the temperature, like if I tell one object has 30 degrees centigrade, one object has 40 degrees centigrade temperature, by looking it, what we can infer in reality means how hot or how cold the body is. Like if it is having more temperature, so we can tell it is more hotter compared to the sun. It is having less temperature, so we can tell this is cold compared to the sun. Likewise, we can infer the degree of hotness or coldness of an object using this temperature. But what actually it depicts is heat. Heat is nothing but the form of energy. Heat is also a form of energy that an object contains. That means this heat can be quantified using this temperature. Understood? And just remember this definition, temperature is nothing but the degree of hotness or coldness of an object. Now we will see some of the terminology related to this soil temperature. First one is albedo. Albedo is nothing but the ratio of reflected radiation to incident radiation. That means if some 70 calories of energy is being incident on a surface, 70 calories is being, out of this 70 calories being incident, how much is being reflected here? If we take 30 by 70, 3 by 7, that means some 0.4 or so. This will be the albedo of the object. What exactly this value represents means how much the object is able to reflect the incident amount of energy. We can tell this is nothing but the albedo. Both are like same units. So albedo is dimensionless quantity. This is very important. Both are energies. So units will be cancelled by calories, and calories can be cancelled. So it is nothing but a ratio. So it is dimensionless. Albedo is nothing but the ratio of reflected to incident energy, or in other way we can tell out of the incident energy how much energy is being reflected by the surface. This is nothing but albedo. Next one is heat capacity. Heat capacity is nothing but the ratio of heat supplied to body to corresponding rise in temperature. That means Q by delta T. This is nothing but heat capacity. Heat capacity means then what will be the units of this heat capacity? Heat will be calories. This will be degree centigrade. So, calorie per degree centigrade. These units don't mug up these units like as it is. Just read the definition and write the unit according to the definition like this. Heat capacity is nothing but the ratio of heat to change in temperature. Heat is represented in calories. Temperature is represented in degree centigrade. So, total heat capacity unit will be calorie per degree centigrade. Calorie per degree centigrade. Next one is specific heat. This is nothing but the heat capacity in relation to the water. This is nothing but the specific heat capacity. The units can be calorie per centimeter cube per degree centigrade. Next one is thermal conductivity. Thermal conductivity is the quantity of heat passing in a unit time through unit area under unit temperature difference between the phases. If we take these are the point A to B, two phases are separated by some x distance. The amount of heat transferring through this x distance in a unit area in unit time t, this is nothing but thermal conductivity. The units of thermal conductivity will be amount of heat transferring, that means joule or calories, per unit distance, that is meter, per unit time, that is second, in unit temperature difference, that will be degree centigrade. This will be unit of thermal conductivity. Next one is thermal diffusivity. Thermal diffusivity will be the ratio of thermal conductivity to heat capacity. That means joule per meter per second per degree centigrade divided by heat capacity units are joule per degree centigrade. What will be the units of thermal diffusivity in meter square per second? This is nothing but thermal diffusivity. Next one is retentivity. Retentivity is the reciprocal of thermal diffusivity. It is equal to the ability of a body to retain heat, how much it is retaining. Diffusivity, how much it is diffusing out, how much it is retaining in its retentivity. These are all some of the common terminology which we are going to use in the soil temperature topic further. Just be thorough with the definition and dimensions of the each and every term associated with the soil temperature. And don't get confused in between this heat capacity and specific heat. If we talk in terms of specific mass or volume, it will be about the specific heat. But in broad, it can be heat capacity. Next is heat transfer in soil. There are three major physical processes which are responsible for the transfer of heat in the soil. That is conduction, convection and radiation. What exactly are these? Let us see these three processes using some simple example. See, if we are burning water in a kettle, okay, this handle which we are going to hold with our hand, after some time, after the water got enough heat, this heat will be transferred to handle. And when we touch this handle, it will be hot. So what exactly it is? The heat is getting transferred not due to the exact movement of molecules here. It is just due to the vibration of molecules till there to here. So conduction is nothing but flow from places of high temperature to low temperature through momentum of molecules. It's just a momentum or vibration we can say, but not the exact movement or transfer of the molecules. Whereas if we see convection, that means water is moving upward and down, it is evaporating as steam, it is getting settled down. So it is nothing but in this process it causes the increase in volume. In case of convection, the volume is getting increased and density is getting decreased. So what's going on here? It is the motion of body itself, that means water itself carrying the heat. It is momentum, it is the motion of body itself. And the third one is radiation. Radiation is just heat is transferred from one place to another without any medium, intervening medium, it will be getting transferred. If we take electromagnetic waves also, electromagnetic waves, it is very important example under radiation. Electromagnetic waves also, it will come under the radiation. Here radiation will be the heat generated from burning, it will be coming under radiation. Next, factors influencing the soil temperature. What are the factors influencing this soil temperature? First one is amount of solar energy. We all know the soil derives its heat from sun. Sun transfers heat to soil. But however, the oxidation of organic matter which is present in the soil with the evolution of CO2, it will also generate some amount of heat. So the quantity of this radiant energy that is reaching the soil, it will depend on many factors like the sun position, atmosphere, slope of the land, vegetation and all. So if we see the position of sun, in case of tropical areas, in tropical areas, how the sun will be, if the person is here, sun will be overhead, in overhead position. And if atmosphere is cloud free, definitely some 75% of solar radiation reaches the earth. So there is an increase in soil temperature. If we take globe, these are Arctic regions or poles and this is equator. What happens exactly? There is an increase in soil temperature if we move from Arctic to equator. Right now, in Arctic it will be very cold, in equator it will be hot compared to Arctic region. So there is an increase in soil temperature. And the amount of radiant energy that is received in these polar regions is definitely less than the energy that is reached in equatorial belt. So the sun position also plays a role in influencing the soil temperature. Next one is atmosphere. In atmosphere, how we can explain this? The longer the distance that the sun ray had to pass through the atmosphere, greater is the absorption of heat by atmosphere, because if it is the sun and it has to pass through the atmosphere, then only it will reach soil. If this is taking more time, means what's happening in between? Some of the energy is getting absorbed by the atmosphere. So ultimately less amount of energy will be transferred to soil. So likewise, the atmosphere should be cloud free or so. Just we saw before, if it is cloud free, 75% of radiation can be reached by the soil. Next is slope of the land. We all know the surface at the right angles to sun, this receives the more heat. See, if it is the sloping land, when the sun rays are falling like this, the rays are, the energy that is falling on the surface, it is getting distributed in the large surface area. But if it is falling like this, in right angles, it is confined to single surface, so it is getting heated up more compared to the sloping lands. Next one is vegetation. If vegetation is there, it will intercept the radiation, so soil temperature will be decreased. If vegetation is not there, that means bare soil, more radiation will be reached to the soil and soil temperature will increase. Next one is soil color. It is a very casual example that we observe in summer also. In summer, what we prefer to wear, white clothes or black clothes? Definitely white. Why? The white has capacity to reflect more. Due to its high albedo, if we can say, if we can relate it with terminology that we learned before, white surfaces have more albedo and they reflect more radiation. What they are reflecting more radiation means they are cooling the surface actually. So light color soils like the white shirt, they will reflect more radiation and cool the soil. Whereas dark color soil, what they will do? They will absorb more radiation and it will increase the temperature of the soil. Next one is soil depth and time. The temperature definitely changes with depth and time of the soil. Heat flow, if we see in atmosphere and also in soil, where it will be slower? In soil, because in atmosphere it is somewhat free to transfer compared to the soil, because soil is more compact compared to the atmosphere, and the deeper the soil layer, the longer it will reach take the temperature to reach it, and lesser will be the temperature fluctuations. And this is the very standard example that we can observe in day-to-day life also. Next one is nature of soil. Nature of soil means if we walk on sandy soils in the afternoon of summer, what will happen? Our feet will get burnt like anything. So, in sandy soils, they will usually get warm up quickly than the clay soils. Why? The thermal conductivity of sandy soils is more than clay soils. What happens if thermal conductivity is more? The amount of heat that is transferred is, free to transfer in sandy soils compared to the clay soils. And there are more factors like specific heat, vaporization, heat of vaporization, conduction of heat in soils and all. But these are all the major factors that you need to understand first before going into exact topic. And if we see another one, that is specific heat. We all know the specific heat of water is 1 calorie per gram. Why water takes more time to heat means it is having more specific heat. More specific heat means more time it will take to increase the temperature of the body. If the specific heat is less means in less time only it will heat the particular body. So only if we take oil and water, water is having more specific heat. So more time is required to rise the temperature of water. In that time only, if we heat the oil, it will burn like anything because it is having less specific heat. So it will reach the high temperature more easily compared to water. Just be thorough with this concept of specific heat. It is very useful in understanding the soil temperature topic very easily. And just understand it. The more the specific heat, lesser the time it will take to rise the temperature. So very slowly it will rise the body temperature. Next is the importance of soil temperature. As we saw these many terminology and also the various properties of the soil temperature, very too high or too low temperature will affect the germination of seeds. And different crops have different optimum temperature for germination also, like wheat will require low temperatures, rice will require somewhat optimum temperature, and some crops like tobacco, they require light in addition to temperature. Likewise, many seeds will have their own preference for the germination in terms of temperature and also light. And absorption of water and nutrients is also impaired under low temperature. And temperature influences the nutrient availability by affecting the weathering of minerals and decomposition of organic matter. When there is more temperature means more decomposition of organic matter, so more CO2 evolution will be there and more heat will be generated in further. So these are all the topics we have to link using these fundamentals. And low soil temperature results in white succulent roots. This is very important. White succulent roots are resulted with the low soil temperature. And low temperature also increases the disease incidence by parasitic fungi. Soil microbial activities and decomposition of organic matter is restricted below 10 degrees centigrade and ceases below 5 degrees centigrade. This is very important. The microbial activity ceases below 5 degrees centigrade, and this 5 degrees centigrade is referred to as biological zero. That means, in terms of biological activity, it is becoming zero at this particular temperature. So, we can also refer to as biological zero. This is very important. And biological nutrient transformations like nitrification, ammonification, etc. are very affected by this high or low temperature, because all of these more or less need 30 to 35 degrees centigrade, and a very high temperature will impair the bacteria that are involved in the particular process. Like that, the temperature should not be more or should not be very less. It should be optimum for any process to occur. And this is all about soil temperature. If you have any doubts regarding this topic, please feel free to contact us with the given details or comment down below. And a very short announcement from the Agri-Edit. That means we are going to launch the master course for ICAR JRF Physical Sciences classes 2024 shortly in November probably. So, if you are interested to enroll in the particular course, please contact us using the given details. And all the best for your preparation. Give your best and